Alright, welcome to today's class. In today's class, I'm going to solve ROSU physics test question for 2020/2021 academic session. Before we proceed, if you've not subscribed to this channel, kindly subscribe now. Ensure you like this video and you can also share it to your friends and classmates. And if you have a question in the course of this tutorial, kindly leave your question in the comment section of this video. Alright, let's look at the question. This is question 1A. When a capillary tube is dipped in a vessel of water, the water rises 5.75 millimeters beyond the surface of the water in the vessel. Alright, now the question, we are given that H, let me change the color of the pen. Take note of this. H is height. H is height or capillary rise. Capillary rise / depression. So that's what H is called. H is called height or capillary rise / depression. It's either rise of the capillary or the depression of it. Alright, in the question we are told that the capillary tube is dipped in a vessel of water and then the water rises 5.75 millimeter beyond the surface of the water in the vessel. So therefore H is equal to 5.75 millimeter. At this point, we are going to convert H from millimeter to meter. We are going to convert H from millimeter to meter. And in order to convert from millimeter to meter, you divide by what? 1000. So divide by 1000. So kindly punch your calculator. If you divide 5.75 millimeter by 1000, what will it give you? It will give you 0.00575 a meter. And this H is the rise of the water, which let's call it HW. The H is the rise of the water. Let me erase it and write it properly. So we have a H subscript W. That signifies the rise of the water. Alright, so the same tube is dipped into a similar vessel of mercury. The first one, the tube was dipped into a vessel of water and the rise is 5.75 millimeter. Now that same tube is dipped into a similar vessel of mercury. Now we are considering mercury. The mercury is depressed below the outside level of the mercury in the vessel. The first one we had a rise. Now we are having depression. If the variation H in the levels of the mercury is 0.2 centimeter. Alright. So the height of the mercury is H, capital letter H and G. The height of the mercury is equal to 0.2 centimeter. Alright, so we are going to convert from centimeter to meter. H is always in meter. Take note of this. So if you convert from centimeter to meter, you're going to divide by 100 because it is in centimeter. So if you divide 0.2 cm by 100, what will it give you? H subscript capital letter HG is equal to what? 0.002 meters. All right, so let's look at the question again. It says, calculate the surface tension of the mercury. Calculate the surface tension of the mercury. Assume the surface tension of the water to be 7.5 multiplied by 10 raised to the power negative 4 Newton per meter. So we are giving the surface tension of the water as 7.5 times 10 raised to the power negative 4 Newton per watt meter. So let's write it down. Surface tension is written like this. So the surface tension of water is equal to 7.5 times 10 raised to the power negative 4 Newton per meter. So we have Newton per watt meter. All right, so this is gamma, and gamma represents surface tension. The W here is the subscript which represents water. So this is surface tension of water. We are also told that the angle of contact of mercury / glass to be depressed. All right, so we are also told that the angle of contact of mercury or glass is 130 degrees. So angle of contact is theta. Angle of contact theta of mercury. So subscript Hg is equal to 130 degrees. 130 degrees. All right, let's look at the question again. Density of water and mercury to be 10 raised to the power 3 kg per cubic meter. 10 raised to the power 3 kg per cubic meter. Alright, so we are also told that the density of water and mercury is 10 raised to the power 3 kg meter raised to the power negative 3 and 13.6 times 10 raised to the power 3 kg meter raised to the power negative 3 respectively. So the first one here is for water, which is what? For water, the density, this is rho. Rho for water is equal to 10 raised to the power 3 and then kg m raised to the power negative 3. This is for water, which is the density of water given. All right, so what's the density of mercury given? The density of mercury given is equal to 13.6 times 10 raised to the power 3 and then kg m raised to the power negative 3. All right, so let's look at the question again. The acceleration due to gravity g is equal to 9.8 meter per second square. All right, so g, which is acceleration due to gravity, is equal to 9.8 ms raised to the power negative 2. All right, so these are the parameters given so far. These are the parameters given so far. The first parameter here is the rise of water or the height, which is 0.00575 meter. The second one here is the depression of mercury, which is 0.002 meter. The third one here is what? The surface tension of water. The fourth one is the angle of contact of mercury. The fifth one is the density of water. The sixth one is the density of mercury. And finally, we have the acceleration due to gravity here. All right, so let's check the question again in order to know what we are asked to do or to find. In the question, we are asked to calculate the surface tension of the mercury. All right, we are asked to calculate the surface tension of the mercury. We are asked to calculate the surface tension of what? Mercury. So surface tension of mercury is unknown yet. So how do we calculate the surface tension of mercury? We are going to look for a formula that relates all the parameters given together. And what is that formula? Now, what's the formula of surface tension? What's the formula of surface tension? The formula of surface tension, gamma, is equal to R rho multiplied by G multiplied by H all over what? All over 2 cos theta. This is the formula of surface tension when you have angle of contact. If you want to understand how to get this formula very well, kindly check the description of this video and you see a link to our introductory video on surface tension. In that video, I taught how to derive this formula. How to derive the formula of surface tension. In that video, you will learn it. Kindly check the description of this video and you will see the link to our last video on surface tension. Alright, so see, this is the formula of surface tension. Now we are asked to find the formula of surface tension of mercury. We are asked to find the formula of surface tension of mercury. So therefore, surface tension of mercury is equal to, we have R here. So we write R. R is a general term. And then we have rho. Rho for the mercury, the density of mercury. And then multiply by acceleration due to gravity, G. G is also general term. And then we have the H, which is the height of the mercury. So we have H subscript Hg. They are all over what? All over 2 cos theta. Now the theta here is the angle of contact. And angle of contact differs. So we have angle of contact for mercury. So this is the formula for finding surface tension of mercury. All right, remember we are given density of mercury. We are also given acceleration due to gravity. We are also given the height of the mercury or depression of mercury, and we are given the angle of contact. So we are not given the radius, and we are also not given the surface tension of mercury. In other words, we are even asked to find the surface tension of mercury. So now we need to get the value of radius R. So how do we get R? Remember, R is a general term. R is a general term. Now don't forget that surface tension, the formula for surface tension is equal to R rho GH all over, or let me write it properly, R rho GH all over 2. This is the formula for surface. This is the formula of surface tension when angle of contact is not given. Take note of this. This is the formula of surface tension when angle of contact is not given. Now we need to find the value of R before we find the value of surface tension. Now let's make R the subject formula. If you make R the subject formula, you have to cross multiply. So Aru rho GH will have to will multiply the denominator here, and gamma will multiply 2. So we have Aru rho GH is equal to 2 gamma. Now we are looking for R. So we simply divide both sides by rho GH. So we have that R is equal to 2 gamma all over rho GH. 2 gamma all over rho GH. Now remember, I told you that R, which is the radius, is a general term. R is a general term. You can use the value of R for water, and you can also use the value of R for mercury. So now let's find the value of R using the parameters given in the question. Let's use that of water. Let's use that of water. Remember that we are given the surface tension of water. We're also given the density of water and the height of water. Now, we can now substitute into this formula. So if we substitute here, we will have 2 multiplied by what? What is the density? What is the density, or what's the surface tension of water rather? The surface tension of water. In the question, we are told that the surface tension of water is 7.5 multiplied by 10 raised to the power negative 4 Newton meter raised to the power negative 1, or Newton per meter. So now let's substitute into this equation. So we have 7.5 times 10 raised to the power negative 4 all over what? All over what is the density of water given? The density of water given is 10 raised to the power 3 kg m meter raised to the power negative 3. So we have here 10 raised to the power 3, and then multiply by what is the acceleration due to gravity g? G given in the question is 9.8, and then multiply by what? What's the height of the water, or the rise of the water? From the question, the height of the water is 0.00575. Let's cross check. That's the first parameter given. The height of the water is 0.00575. Alright, so at this point, we are going to punch our calculator. Kindly punch your calculator and confirm the answer. So at this point, R, which is the radius, is equal to 2 multiplied by 7.5 multiplied by 10 raised to the power negative 4. It would give you 0.0015. And then all over, our denominator becomes 56.35. Our denominator becomes 56.35. So if you divide 0.0015 by 56.35, what will it give you? R, which is the radius, will be equal to 2.66 times 10 raised to the power negative 5. R, which is the radius, let me write it properly. The radius R is equal to 2.66 times 10 raised to the power negative 5. Now we've gotten the value of R. And remember, I told you that R is a general term. R can be used for water. and R can be used for mercury. That's why it does not have a subscript here. Take note of this. R is a general term. It can be used for water. It can also be used for mercury. Alright, so we can now substitute the parameters given in the question into this equation. Remember, in the question, we are asked to find the surface tension of mercury. The surface tension of mercury. And before now, we didn't have the value of R, which is the radius, which we calculated for. So now we have gotten the value of the radius. So we can now substitute into this equation. So the surface tension of mercury is equal to, what's the value of R? Is equal to, the value of R is 2.66 times 10 raised to the power negative 5 multiplied by, what's the next parameter here? The next parameter here is the density of mercury. So now let's check. What's the density of mercury? The density of mercury, which is 13.6 times 10 raised to the power 3. 13.6 times 10 raised to the power 3. So you write here 13.6 multiplied by 10 raised to the power 3. So what's the next parameter here? The next parameter here is acceleration due to gravity. So we have multiplied by, acceleration due to gravity, as given in the question, is 9.8. And then multiplied by, what's the last parameter given? Yeah, let me reduce the font so it can contain. So the last parameter given here is the height of mercury. So what's the height of mercury? The height of mercury given in the question is 0.002 meters. All right. So we have here 0.002 meters. So we are done with the numerator. So all over what? All over what? The denominator here is 2 cos theta. So we write 2 cos theta. So what is theta? Remember, theta is the angle of contact. And the angle of contact for mercury is 130 degrees. So we write 130 degrees. Now let me reduce. Alright, so I'm going to reduce the font here so you can punch your calculator and give me the answer. Alright, so this is the font. 2.66 times 10 raised to the power negative 5 multiplied by 13.6 times 10 raised to the power 3 multiplied by 9.8 multiplied by 0.002 all divided by 2 cos 130 degree. So kindly punch your calculator and give me the answer. Alright, so for the numerator, we are going to have 0.007090496. So this is the numerator. All over 2 cos 130 will give you negative 1.28557. All right, so this is it. And here we write the surface tension of mercury. All right, so if you divide through, you are going to have surface tension of mercury will be equal to what? Negative 5.5 times 10 raised to power what? Negative 3. Alright, so this is the surface tension of mercury. Now it is negative. The negative here tells you that it is depression. The negative reveals that it is what? Depression. It is not a rise. It is not a rise. It is what? Depression. So that's what the negative reveals to us. That's what the negative reveals. So instead of writing negative, we can just leave our answer in the positive format. So instead of writing negative, simply write your surface tension as 5.5 times 10 raised to power negative 3 Newton per meter. Alright, so simply write it this way. Instead of writing the negative, simply eliminate the negative and write 5.5 multiplied by 10 raised to power negative 3 Newton per meter. Alright, so this is the answer. Alright, now let's solve the next question. Question 1b. If 21 grams of alcohol of density 0.7 gram per cm cube is mixed with 10 grams of water, what would be the density of the resulting mixture? What would be the density of the resulting mixture? All right, let's write solution. Solution. Our first task here is to write down the given parameters. First of all, we are given that the mass of alcohol, M subscript A, is equal to 21 grams. The mass of alcohol, if 21 grams of alcohol, that's to tell you that the mass of alcohol is 21 grams, and the density of alcohol is given as 0.7 gcm raised to power negative 3. So the density of alcohol, which is rho, is equal to what? The density of alcohol is equal to what? Let's check. Is equal to 0.7. So we have here 0.7. So the density of alcohol is rho subscript A. The density of alcohol is rho subscript what? Subscript A. Now, let's continue. What's the next parameter given? He said, if 21 grams of alcohol of density 0.7 gram per cm cube is mixed with 10 grams of water. So we are told that the mass of water is 10 grams. So the mass of water, M subscript W, is equal to 10 grams. Alright, so let's check again. What would be the density of the resulting mixture? Now remember that 21 grams of alcohol was mixed with 10 grams of water, and we are given the density of alcohol alone. So we don't have the density of water yet, and we are asked to find the density of the mixture. So how do we go about it? Now, having written the parameters given so far, so what are we going to do? Take note of this. Density. Remember that density, rho, is equal to mass divided by what? Volume. Remember, density is equal to mass divided by what? Volume. And then volume is equal to what? If you make volume the subject formula here, volume will be equal to mass divided by density. And we are asked to find the density of the mixture of both water and alcohol. So what's the formula we're going to use? The density of the mixture. So density subscript mixture is equal to, remember that the formula of density is mass divided by volume. Formula of density is mass divided by what? Volume. Let me write it properly. Mass divided by volume. And the mixture is both, it contains water and alcohol. So we simply write the density of the mixture is summation of mass and then summation of divided by summation of volume. So we are going to find the mass of water and the mass of alcohol, and also the volume of water and the volume of alcohol. All right, so at this point, let's now find the volume of alcohol. V subscript A, which is the volume of alcohol, is equal to what? It is equal to mass of alcohol all over density of alcohol. Now let's check. Let's check if we have mass of alcohol and density of alcohol. Yes, we have it here. The mass of alcohol given is 21 grams and the density of alcohol given is 0.7. All right, so the volume of alcohol, VA, is equal to what? It is equal to 21 grams divided by 0.7 gram cm cube. All right, so at this juncture, gram will cancel gram. So therefore, the volume of alcohol is equal to 21 divided by 0.7. What will it give you? It would give you 30 cm cube. 30 cm cube. So this is the volume of alcohol. This is the volume of alcohol. Now let's now find the volume of water. The volume of water. Volume of water, V subscript W. Remember the formula of volume. Volume is equal to mass all over what? Density. Mass all over density. All right, so what's the volume of water? What's the mass of water rather? Let's check again. The mass of water, as given in the question, is 10 grams. The mass of water is what? 10 grams divided by. Now in the question, we are not given the density of water. Now recall, the density of water, if you approximate the density of water, it would give you 1 gram cm cube. You can also confirm the general density of water. The density of water, if you approximate it, it would give you 1 gram cm cube. So all right, so at this juncture, we are going to divide through. So gram here cancels gram. So the volume of water, V subscript W, is equal to 10 divided by 1 is what? It is 10. So we have 10 cm cube. So we have now gotten the volume of water and the volume of alcohol. All right, now let's substitute into this formula, which is the density of the mixture. Now recall that the density of mixture is equal to summation of mass all over summation of volume. So we have here, it is equal to what? Summation of mass. So we can simply write mass of water plus mass of alcohol divided by volume of water plus volume of alcohol. All right, it is equal to, what is the mass of water? The mass of water is 10 grams, and then plus the volume, the mass of alcohol rather, is 21 grams. And then all over, what is the volume of water? From the question, the volume of water is what? 30 cm cube, from what we calculated. And the volume of alcohol is what? 10 cm cube. All right, so we are going to add it up and then divide. So we have here 10 plus 21 gives us 31 grams divided by 30 cm cube plus 10 cm cube gives us 40 cm cube. So therefore, the density of the mixture is equal to 31 grams divided by 40 cm cube. Kindly punch your calculator. It would give you 0.775. 0.775 what? What is the unit of density? What is the unit of density? The unit of density is gram per what? Cm cube. That's the unit of density, gram per cm cube. All right, so this is our final answer. Remember, in the question we are asked to find the density of the mixture. So therefore, the density of the mixture is 0.775 gram per centimeter cube. All right, so we have come to the end of this class. If you enjoyed this class, kindly type "I enjoyed this class" in the comment section of this video, and ensure you like this video. If you've not subscribed to our channel, kindly subscribe now. See you in our next class.